Okay, so in this video, we're going to talk about polynomials, which is basically kind of like a quadratic function, like, y equals x squared. But now we're getting we're adding more terms and we're adding more powers. So instead of just being like x squared and then, plus 3x plus 2, right? We're now going to have maybe x to the fourth minus 5x to the third plus x squared minus something. So it could be basically, it could be any number of terms. Even one term could be a polynomial, right? And these have to be whole numbers. All the powers are whole numbers. And that's basically it. They're not negative either. They're whole positive numbers. So that's kind of what we're talking about here. Let me just kind of pull up a resource so I can copy this down. All right, so polynomials, this is kind of like a definition, basically. Polynomials are they're smooth curves with no breaks and they're continuous for all real numbers or discontinuities. I don't know if you know the term discontinuities, but we kind of talked about it very informally. Yes. They are defined for, I guess, all real numbers. This is the symbol for that. In other words, the domain is negative infinity to infinity. Okay, does that make sense to you? The way that I wrote that? Sorry if that's confusing. So in other words, polynomials are curves. There's no breaks. They're beautiful. They're continuous. They're nice. We like them a lot, okay? And the degree is the highest exponent. The highest exponent of the polynomial, I guess. The highest exponent, we'll call it n, of the polynomial. Is the degree. Cool. And we'll talk about just with x's for now. There's some more subtleties for that. So let's just look at this and kind of talk about it for a minute. This right here, the degree, there's no exponent, right? There's like literally no exponent. So if there's literally no exponent, the degree is actually 0. So this degree is 0. And we have a name for it. You probably even learned it in algebra. It's called a constant. So these are just examples, by the way. What's the highest exponent of that? Well, the highest exponent's 1, and that's called a linear. And as you probably know, you spend a lot of time on that in whatever, 8th, 9th grade, linear, y equals mx plus b. And then in algebra 2, algebra 1 and algebra 2, you spend a lot of time on this one, which is 2. And that's quadratic. And my job is to make sure, I think you did a little bit of this with algebra 2, maybe, but my job is to make sure you know all the other ones. And we don't really go past I don't know, even if it's 5 or 6, at that point, it's all kind of the same. So it kind of plateaus a little bit, you might say. Obviously, this is more complicated than this, but this degree is 3, highest exponent. So let's just, again, kind of look at that. Degree is 3. This degree is 4. This degree is 5. It's not always the first number, but if it's written properly in standard form, then it is. And you might remember this from before, cubic. I'm sure you know that. Quartic, like a quarter. Quintic. Okay. We want to talk a little bit about the end behavior of the polynomials. This is a pretty easy thing, but it's easy to kind of overlook. It's one of those things that's sort of easy, and that makes it hard. I don't know if that makes any sense. You know what I'm saying? So what you want to do is look at the following. Let's see if I have a highlighter here. Oh, I literally do. Great. So we have to look at the following: the power and the coefficient, okay, of the leading term. So the leading term is the highest one. So the leading term, I guess I should write that in the corner just so you don't miss it. Leading term is the highest power. It doesn't matter if it's written in the wrong order. Like this could be written in the wrong order. The leading term is the highest exponent. Do you get that? Because I'm going to try to trick you, as you know. Okay. So it's not leading if it's written in the wrong order. That's all. Okay, so you look for the highest exponent. So if you look at this example, see these four things. These are your four options. So I don't love how they organize this. I'm going to try my best to kind of color this in a little bit better so you can kind of see what I'm talking about. So we've got this first one. This is example 1, right? Then you have example 2 here. I don't know if the green shows up well, but that's supposed to be a green 2. I know it's not great. Can you see the green 2 at all? There's a green 2 there. All right. And then we have example 3. I don't like how they wrote it. That's why I'm trying to help you out here. And then we'll have example 4. Okay. So if you have an even power and a positive coefficient, it's just like a quadratic. It's going to go up. So we have to write out the end behavior in a specific way. I'm going to try to write it with pencil. Nah, I'll just try to write it with, I'll try it with pencil. Let's see how it goes. So what we do is we write as x gets big, y does what? What happens as x gets big? As x gets big, what does y do? Does it get big or small? As x gets big. Big, right? Yeah. So as x is going to infinity, as we go this way, y is going this way. As x goes up, y goes up. They go up together. And we have to also do as x goes to negative infinity. Okay, and then we'll say y goes to. What does y do as x goes to negative infinity? Does it go up or down? As x goes this way, y goes up. Yep. Yeah. This notation right here, have you done it before? I bet you did, because you had Miss Sypek, right? And she did it. Of course. Thank you to Miss Sypek. So that is end behavior there. Then we talk about this one. Well, it's negative, so it's reflected, right? This is where the transformations kind of help us out. So now it kind of messes up our thing. It actually says as x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y also goes to negative infinity. And they're going together. Now this is an even power. Even power. That's what's happening here. Even power. That means if it's a fourth, it's going to do the exact same thing as this. If it's a sixth, it's going to do the exact same thing as this. Okay? That is called the leading coefficient test, or whatever you want to call it, end behavior. All right. Let's look at the next one. These are odd, so they do the other thing. Remember we just talked about even and odd functions in this class for like a minute? Like the f of x and the f of negative x and the negative f of negative x? That's what that is. So this is an odd function. It has an odd power. See the connection? Kind of interesting, right? And as x goes to infinity, y will also go to infinity. So as x gets big, y gets big. And as x gets small, y gets small. Okay, that's an odd power. That would be the true if it was a fifth or a seventh or a ninth. Or if it was a x to the, let's make this x to the fifth plus 2x squared minus 4x plus 1. That would still be exactly like this. Okay, because all we care is that this is a positive coefficient on the first one, and it has an odd power. That's it. It's a negative coefficient. It's an odd power. Doesn't matter if it's a 3 or if it's a 7. Plus 2x minus 8x to the third. This is going to be, as x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y goes to infinity. And that might be all we have for today. I mean, there's some examples coming up where you'll just practice it. We'll talk about turning points. But I just wanted to get a little bit of those definitions out of the way. A lot of it is stuff you know. We'll see you in the next video. We kept it nice and short. Peace.